Cool, it does. Okay, yeah, so I'm Greg Hurrell, as Pete said. I work on the core team on Relay at Facebook. Yuzi Zheng's also here. She works with me, right next to me. We've also got Matt Mahoney, who works on the iOS side in New York. So they'll be joining me a little bit later to do the Q&A part. But for now, I'm going to be talking about Relay. So this is what we're going to be covering today. For those of you who may not know what Relay is, I'll begin with an intro to kind of what its function is and how it works, before moving on to what we're calling Relay 2. It's not really going to be called Relay 2, we think, but we do actually, we need a name to like attach to this thing that we've been working on for the last few months. So we figured, yeah, let's just take a 2 on the end and then we can grep for it in the code base and we can keep the files separate. It's effectively a ground up rewrite, so we did want to keep things isolated. So let's dive in straight away with the first part, which is where is Relay today? So the one sentence intro to it is that it is a framework for building data-driven applications with React and GraphQL. Let me unpack that phrase just a little bit. You've probably seen this rendition of what is an application before. The basic idea is that you can think of it as a function that maps a bunch of data that you have to a view that the user sees and interacts with. But what is the shape of that data? And what is the shape of the view? Well, it turns out that typically in modern user interfaces, the data is hierarchically shaped and views are hierarchically shaped. So we effectively have these two hierarchical things, and it's really convenient to have a query language that is also hierarchical to express your data dependencies. And so when you have these things all lining up, then you get this nice impedance match throughout. And that is what you get when you use React as your view layer. Your data dependencies come in as JSON, and you use GraphQL as a query language, because they're all hierarchical. Now I'm going to show like a somewhat visual representation of these things so that you can get a sense of what they look like if you haven't seen them before. This is a user interface. As I said, these tend to be hierarchical because we build things out of components nowadays, and we make complex components out of simpler ones by nesting them inside and composing them together. And when you render a complex UI like this, you end up needing a similarly complex set of data to fill in all the little gaps in that UI with variables. Now, the shape of this data tends to match the shape of the UI, or at least it would in an ideal world. You as a developer should not have to concern yourself with scurrying off to a bunch of different endpoints and assembling all this data into the right shape and parceling it out to the different parts of your UI. Ideally, you'd have a framework that would enable you to fetch all this and shove it into the UI. And so this is actually what GraphQL starts to give us. And one of the great insights of GraphQL is that the definition of your data fetching layer should be driven by the user interface, by what people see, by what people interact with. Because if you ask users what your product is, that is exactly what they're going to describe. They're going to describe like a list of friends or a calendar where they can look at events, and the data model is really should exist only in service of that, not in service of the particular implementation details of your MySQL database or your MongoDB store. It really should be the product that drives it, kind of from the outside in. And when you use GraphQL, that is what you get. You don't start with some abstract UML diagram, you start with a user interface, and you start by listing off the things you need. And so I'm going to show you a snippet of what GraphQL looks like. This is a simple one. GraphQL queries consist of fields, and those fields can themselves contain fields. So in this case, the top level field we have here is the viewer. You'll notice that this kind of looks a bit like JSON, except it doesn't have any values. It only has keys. It also doesn't have punctuation. Probably, punctuation is overrated in general, I think. So no colons, no commas, no quotes. We can traverse through this thing from the top. Inside the viewer, there's a set of things that the viewer can see or have access to, such as their name. We can look at their GitHub account details and get the handle on GitHub. Or we could ask what their title is or their username. So when we send this to a GraphQL server, we get a response back that has pretty much the same shape. Here's an example with some of my information. There's my GitHub handle, my name, my job title. And you notice that they match because they're the same shape. So, here's another example of GraphQL. I'm going to show you 3 examples in all, in order of increasing complexity, just to introduce the concepts to you. So, the purpose of this example is to show you that GraphQL is not just about grabbing bags of data. At its heart, it's actually a type system. And the highlighted yellow part that you can see here is evidence of that type system. Basically what this says is when you're looking at the node identified by the key 4, if that record happens to be a user, then you're going to fetch these fields on it. And you can imagine how our system might have a bunch of things that you could fetch using this node interface. It could be pages, it could be events, it could be cars, accounts, and you'd be able to specifically target types using this notation. Now this node field up there demonstrates another feature of GraphQL, which is that fields can take parameters or variables. And the fact that Facebook uses a node field isn't something that GraphQL itself specifies as a requirement. It's just a convention that kind of emerged when we built it out several years ago in our iOS app. We found it's really useful to have this generic interface for refetching an arbitrary object. And so when you combine these 2 things, the ability to refetch an arbitrary object and the ability to target that object depending on the type of the fields, you have a very powerful and expressive system. So what are some other things that type information enables? In addition to targeting things on a specific object type, we can do generalized validation. So we can verify, for example, that you don't ask for address on a car, which wouldn't make any sense. We can also do things like automatic code generation. Using the type information in the schema, we can make, in any language we want, a class that can model this kind of object, or that can pass a network response that corresponds to this kind of object and turn it into an instantiated version of that model type on the client. So let's look at another example. That is the response that would come back for that query. Look pretty much like the old one, the hierarchical and the shape matches. Here's the most complex example I'm going to show. This shows fields and variables on those fields, highlighted there in yellow. And specifically what this query is showing is what we call a connection. It is somewhat of an unfortunate name because I think for a lot of engineers and technical people, connection probably brings to mind physical connection or network connection. This is really about pagination. And I think the reason why we settled on the connection terminology is because when you think of all the data in a storage system, you can conceptually model it as a graph. And you have nodes and you have edges between them that you could call connections. And when you have a one-to-many relationship, it could be useful to paginate through that one-to-many collection by looking at the edges between the nodes. So we call this thing connection. It is one of the things that I wish we could change, but it's kind of the way it is. And once again, this is not something that GraphQL itself mandates. It is a convention that we discovered and found useful at Facebook. And so all of our apps use this pattern for pagination. And Relay knows about this pattern and can do a lot of work that you would otherwise have to do manually based on the fact that it can rely on the shape of these things. And so the notable things about this shape are that they are parameterized such that you can say how many items you want, and you can also say where you want to start fetching. In this case, we want to get the first 3 items in the feed after a certain point in the feed. That after variable refers to a cursor. And you can see that as we fetch these 3 items back from the, I'm going to try the laser pointer, there you go. When we get these 3 items back, we're actually going to get a list of edges, and each edge is going to point to a node, and inside each node we can pull extra information from the server. We can also get some information that aids with pagination, such as what is the cursor at the end of this connection. That will enable us to fetch the next page. And we've also got this boolean here which tells us whether we should even bother trying to fetch the next page. So this is a really useful model for pagination. And that is what the response would look like. You'll notice that the shape matches, but also that this is the first place we've seen an array. So we get an array of edges back. And our cursors look like this. But that's arbitrary. Anything that's a string will do, right? We're just base 64 encoding some arbitrary goop there. So, now we know a little bit about what GraphQL looks like. Are there any questions from people who have or haven't seen GraphQL? No, it's all pretty clear. Cool. I imagine most people here have seen React because of the nature of the group. It is the ReactJS Meetup. So this is an example of a typical React component. Effectively, it's a function from props to a description of what the UI should look like. And you can see here, I want to render a profile pic given a name and a URL to that pic. So what I'm going to do in Relay land is accompany that description of the UI with a description of the data that I want to render. And so this is a fragment. It's a little piece of GraphQL that can sit inside my JavaScript component, and it describes exactly the data that that component needs in order for it to render. And so as I start composing these components together, and those fragments get composed together, I eventually arrive at a total description of all the data that I'm going to need to render the entire application. And so this could end up being quite a large query. And Relay is effectively the glue that holds all this together. So we're going to basically take React, which is a wonderful solution for building user interfaces, and GraphQL, which is an expressive solution for specifying potentially quite large data requirement. And then we're going to put this thing in the middle here that's going to basically stick it all together for us. And it's going to do it efficiently in aggregate. It's going to deliver good performance, and it's going to provide developers with a great ergonomic experience. So that's basically what the goals of Relay are. And now I'm going to just give you an update on the status of the project as it currently stands before I dive into the future. So we're obviously using Relay at Facebook. We're using it extensively in our React Native apps. Pretty much every React Native app that Facebook has made has used Relay to fetch its data in some way. So that includes things like the Ads Manager, which was one of the first ones to ship, the Groups app, and of course the Blue Facebook app itself. Obviously not all of the data is fetched through Relay because not all of the app is written in React Native, but parts of it have been ported to React Native. The first one was the Pokes dashboard. Who has used the Pokes dashboard? It's a kind of weird feature that continues to exist in the app for some reason that escapes me. But it is effectively the testing ground that we use to apply all of the Relay experimental features. If you want to see the current bleeding edge of Relay development, just use Pokes. And hopefully it'll be more stable, more reliable, faster.
You might have to dig in a bit to find it.
Yeah, it's kind of hard to find. It's a bit of a challenge.
Use the search bar.
Yeah. So in addition to React Native apps, we also use Relay on the web. And we use it in a bunch of places on the mobile site. We have a bunch of internal tools, such as our internal issue tracker that use it. And of course, on the main Facebook website, we use it. And in terms of open source, we open sourced just over a year ago, in mid-August. And we're pretty happy with how it's going. Probably the largest external users of Relay that I'm aware of are Twitter and my blog. Actually, there's probably some other companies that use it more than my blog does. We've had some significant and complex PRs contributed by users outside of Facebook. And we also have like a lively ecosystem of third-party tools that engineers from outside Facebook have built. So examples of these, things like server rendering support, which we had internally but didn't really work externally, were made possible by third-party pull requests. And there's a couple of fairly popular libraries that exist in the ecosystem that have been made by third parties, like React Relay Router for routing, the Isomorphic Relay project, which bundles up all of this server rendering stuff quite conveniently. And there's also a newer project that just came out a couple months ago called React Relay Network Layer, which is a kind of middleware-style, highly configurable way of customizing the behavior of Relay. That is starting to get some traction. So that's Relay today. Let's talk about Relay tomorrow. Our goals for this project. Relay had always been architected with performance in mind, but we knew that we wanted to drastically improve the performance on mobile devices. Mobile devices, as you know, tend to be underpowered compared to desktops, and also they suffer from typically intermittent or low bandwidth network connections. And so it's pretty much the hardest environment in which to build a good user experience. But it's the problem we needed to solve. So in order to do this, we knew that we had to make Relay itself much simpler than it was. We're only going to get faster by stripping out complexity and by stripping out work. And as a secondary benefit of this, it's going to make Relay more predictable and easier to understand, not only for you potential users, but also for us. The hope is that by making the system easier to comprehend, we'll be able to iterate on it faster. So we basically didn't want to do an incremental upgrade. We wanted to go to a blank slate, start again. We wanted to place a big bet with a high probability of failure, but a potentially huge upside. And so in order to do this total rewrite, we started by asking ourselves a question. If we're going to go to a blank slate, what are the core parts that we have to preserve? What's the essence of Relay and what's the bit that has to stick around so that we can do all this other stuff freely on top of it and break all of our previously held assumptions? So one of the key features that we knew we had to cling to was this notion of a declarative API. You shouldn't have to worry about how your data is going to be fetched. Possibly you shouldn't even have to worry about when it's going to be fetched. The idea is that the framework should orchestrate the fetching for you. That is something we definitely wanted to keep. And closely related to that, we knew we wanted to keep this co-location of GraphQL fragments with the React components that needed the data described in those fragments. And the reason why we consider this to be really powerful and worth preserving is because it enables component local reasoning. And this is something that you get when you develop with React for the first time. You'll notice that you're suddenly able to solve problems that are much more complicated than you previously could. Or at least you can solve them with fewer bugs, with less mental effort. And Relay has always really tried to extend that simplicity to the data fetching concern as well. And we think that thinking locally to the component is what makes it that simple. Because it means that you can see right next to the render method the data that's going to be requested and passed into that component. You can make changes locally without worrying about underfetching or overfetching because the list of the data is right there next to the render method. And furthermore, you can do this without having to worry about what's going to happen over the other side of the app where some team is like potentially requesting overlapping or not overlapping data. And you can trust that the framework will reconcile all of that together and aggregate it in an efficient way, and you don't have to worry about any of that stuff. So we definitely knew that we wanted to keep co-location, which meant that we wanted to keep this shape. Files are still going to be written as JavaScript modules, and they're going to have a React component inside them, and they're going to have a GraphQL fragment or fragments inside them. As I said before, performance has always been something that we cared about, and we've done a number of things from the beginning of Relay with performance in mind, but this was something that we knew we needed to keep and double down on. So what are some of the things that we have always done that we're going to continue doing? One is this notion of aggregation. You might have 1,000 GraphQL fragments in your app, but we should still only send one query. And likewise, caching. You shouldn't go to the network to ask for data you already have. And likewise, in terms of a React lifecycle hook, we should provide an efficient should component update method by default, which is aware of Relay and how it works, so that you don't have to worry about parts of your UI rendering that don't need to update when new data comes in. So those things that I've talked about over the last few slides, those are the bits that we wanted to keep. Pretty much everything else is up for discussion. And we knew that we wanted to place some big bets. So let's look at what some of those big bets were, specifically in the context of mobile devices. These are the ones that I'm going to talk about. One is persisted queries, which is something that you might have heard through various channels. It's not something we've been able to open source, but it has existed in Facebook for a while. But people know this thing exists, and we decided we wanted to bring it to the public. Another one that we've talked about in public that we recently built is this new API called Relay Connection for dealing with those paginated connections. We wanted to bring that to the public as well. And finally, possibly the biggest idea of all is we wanted everything to become fully static. So I'm going to go into these three bets and a couple of other things before the end. So let's start with persisted queries. Persisted queries are quite hard to implement in Relay because of its dynamism. Let's look at what generally happens in the overall lifecycle of a request. Network performance is not only about the data you get back from the server. You also have to send a request in the first place to get that data. In GraphQL, that request could actually be quite large. So to give you an example, the newsfeed query for a Facebook newsfeed could literally number of the order of thousands of lines of GraphQL. And so uploading that on a terrible mobile connection is actually a huge source of latency and slowness. And the response comes down. There's not a hell of a lot we can do about that other than the tried and true methods of not asking for data that you don't need and using gzip compression and all these other things. But this request part is actually some pretty low-hanging fruit that we can use to make things much faster. So let's have a look at what persisted queries look like. Here is an example of a non-persisted query. I took this out of a sample app, a list of posts, but it goes on for thousands of lines, so I've cut those out there. Why would we send something like this over a crappy mobile network connection when we could send something like this, right? That'll fit in a single TCP packet. Basically, we take that big multi-thousand line blob, we save it to a database, we get an ID for the thing that we saved, and then in the future, instead of sending the blob, we just send the ID of the thing that we saved, along with whatever variables are required to make the query work. So that is what persisted queries are. And if you're curious to see how these are taking shape in the open source world, there is a pull request to the Express GraphQL project. To my knowledge, it hasn't been merged yet, but this shows how you could implement query persistence using at least the node stack. So the other thing that persisted queries enabled, at least in React Native context, is this possibility of doing what we call native prefetching. So it's not just about how small your upload is when you're making the request. It's also about when you send the request. Can you send it sooner? Well, it turns out that in a React Native app, you can send it sooner. In a classic world, you have to wait for a JavaScript context to initialize and load all the JavaScript files in, pass them, compile them, execute them, figure out what query to send, actually send it at this point, and then you get the data back and can process it. But if you've got persisted queries, before you even start booting the JS context, you already know what data you're going to fetch. So you can actually start fetching on the native side at the same time as you're booting the JavaScript context. And so it's possible, depending on the speed of your network, that the data might even arrive by the time you finish loading the JavaScript. And you could start processing it that much sooner. And you can imagine in an app that's complicated, like a hybrid app that is partly native and partly React Native, that you could do this before the user even attempts to navigate to a React Native view. And you'll be totally ready by the time we start booting up the JS context. So this particular change alone can save literally hundreds of milliseconds on a mobile device. So it's a huge win. Let's talk about the other big bet that we've made lately, and that's called relay connection. Now this is a lower level API for dealing with those paginated connections that I showed an example of earlier. And it really does two things. One is that it provides more granular control over how things are garbage collected in a collection. So you can imagine something like the Facebook news feed, which has infinite scroll. A user could scroll for a long time, and by the time the stories that they saw at first have scrolled tens of thousands of pixels off the screen, they're unlikely to look at those again. You might want to free those and recover the memory. So relay connection allows you to do that. It allows you to mark ranges within a connection as uninteresting and release them back. The other thing that it does is it effectively allows you to stream edges in one at a time. So you could do something like request 1 or 2 entries at the head of the connection, and then for the remaining 5 or 10, just have the server send them down one at a time as they arrive. And the nice thing about that is you're getting it in smaller chunks, so you can process it incrementally. So here's a pictorial representation of what that might look like. Under a classic connection model, just say you want to get the first 10 items in the list. You fetch them and normalize them all at once. Normalizing here is just the word we use to describe processing the server response. And then you render all 10. In relay connection, it's possible to do something that looks like this, where we start fetching and we get these stories one at a time, and we can normalize them and render them as we go. So we're doing roughly the same amount of work. We might even be doing a little bit more work because there's some overhead in doing this, but the user experience is so much better because of the incremental nature of it. And so in between all these render events, the user can be doing gestures, they can be seeing animations, and all user interaction can be processed fluidly by the app, which is super important for the user experience. So those are two pieces that we built and actually started testing with Relay 1, the current Relay. But we knew we wanted to do much more than this. And so let's talk about some of the more drastic changes we wanted to make. We started with a question, and that question was this. We know we have a thing called persisted queries, and we know persisted queries are really cool. What would it be like if we made literally every single query in a Relay application persistible? We know there's a huge potential performance upside here, but there is a problem. And that problem is that Relay is incredibly dynamic. And dynamism is kind of like the kryptonite for persisted queries, because you can't persist something if you don't know what the query is ahead of time. So I'm going to give some examples of how dynamism basically pervades all of Relay in its current form. These were effectively obstacles that we had to remove in order to get to totally static persistible queries. So here's one example. It's what we call diffing. So we start on the left there with a query that describes the data requirements for a view that we're about to navigate to. And Relay itself contains a cache. So we can look at that cache and say, well, given this query, what parts of it can I already answer without going to the network? And we strip those pieces away. And what's left is what we call a diff query. It describes the query necessary to get only the data that we don't have. It's generally smaller. And so in the best case, it's so small it's actually 0 in size because we have all the data and we don't even have to hit the network at all. But the problem with a diff query is that it is dynamically constructed. We obviously can't know it until runtime, because only at runtime can we know what's in the cache. Here's another example of dynamism in Relay. This is a diagram of what we call deferred queries. So I'm going to ground this in an example of a product. Say you have a blog, and you're looking at the index page of that blog, and you can see the title, maybe you can see a bit of a leader for what the content of the blog is, but you can't see any comments. And somebody clicks on the comments link, and that takes them to a permalink page. In theory, you should be able to show something to the user straight away, because you already had the title, you already had the metadata, you already had the leader of the blog post. You don't have the comments yet, though. It would be really bad if you blocked rendering that page on having all of the data. Why shouldn't you just render with the part that you already have? So what splitting off deferred queries allows us to do is draw a boundary in the query at the point where we stop seeing required data and start seeing deferrable or kind of optional data. So in the example of the blog post, we would mark the title, the author, the date, the first paragraph, all of those things would be required. But the comments and everything underneath them, those would be deferred. And so this is another thing we do at runtime. We basically traverse through the query looking for boundaries that have been marked as deferred. At that point we cut things off and we turn one query into many queries. In this diagram I've just shown two. There's a required query and a deferred query, but in a real app you could actually have nested deferred queries and many multiple ones of these. So the nice thing about this is when it hits the server can process the required query, start sending it down to the client can start processing that response as soon as it gets it and render without waiting for this second part. So in combination with diffing, this is a really powerful idea, because you can imagine that maybe in the required query we already have all of the data, so it diffs away to nothing and we don't even have to hit the network at all. So the user sees the blog post and then a little bit later they see the comments. So nice user experience, but very dynamic. I'm going to show you at an even more fundamental level why Relay queries in their current form are dynamic. You notice that this thing here is a function. And this is what we call an ES6 template literal. This is interpolation of arbitrary JavaScript code. This is how one component expresses that it wants to compose the fragment from another component. So you can imagine this thing could be the title bar of an index of my blog posts, and then I want to get some tags as well, and they're rendered by a different component, so I have to effectively compose them in. So what we do is we take this template literal and we have a build step that turns it into an AST. By using that JavaScript interpolation, we just use this ... spread syntax. And these names here need to be globally unique. but there's no evaluation at runtime. So one obvious consequence of this is that if we look at all of our JavaScript files at build time, we can discover all of these fragments and we can have ahead of time knowledge about how queries compose in the app. But there's a problem. If they're just strings and they're static, how can we pass variables? We like variables, they're useful. It's not possible to pass variables to fragments in GraphQL. It's possible to pass them to fields, but not to fragments. So what are we going to do? Or is it possible? Maybe we can do something. Turns out, if we polyfill GraphQL, we can totally do whatever we want. And we can have the features that we want in GraphQL tomorrow, today. So we did this. And the way we do this is by using this directive syntax, which starts with that symbol and an arbitrary word. It's basically a way to arbitrarily extend GraphQL with pretty much whatever you want. It adds metadata to the AST, and then in your toolchain, you just teach your toolchain how to process that metadata and do stuff. So let me show you how we're using directives to do stuff. This is what it looks like to pass arguments into a fragment. We just use an arguments directive, and we can pass arbitrary arguments. And on the receiving side, you can also use a directive to declare the kinds of parameters that your fragment should take. So we use that argument definitions directive here, which basically allows us to specify things like the type of the argument that we expect and what its default value should be. And like I said, we need to have knowledge of the entire corpus of components in an application in order to be able to make sense of all this. So we look at the entire code base, extract a bunch of GraphQL documents, pass it through a compiler, and that compiler has a number of transforms, and at the end it spits out an AST for us that we will be able to persist to the server or execute on the server. So we can do things like print that AST to a string, just like the old days. We can save it in a database, and we can also analyze the flow of variables through the system, which I'll talk a little bit more on a subsequent slide. And this is what that AST looks like. You'll notice it looks a bit simpler and cleaner than the Relay 1 one. It's just a JSON-compatible JavaScript object. There's no evaluation going on here. It's just strings and what we would call scalar values. This AST can be used to do a bunch of things. We can use it to process server responses. We can use it to read data out of our cache. And we can use it to do a bunch of optimizations. So those optimizations are enabled by whole program analysis. And I'm going to look at some of the analyses that we do and just describe them on the next few slides. The first one is we have to figure out how to flow variables through the entire query tree. So a fragment can get its variables from a couple of different places. It can import it from the global, top level query, or it can receive a value from its parent, or it can have a default value, a literal default value. And so what we're able to do is starting at the top of the query, traverse down through, passing literals down, passing defaults down and turning them into inline literals, or into references to globals. And at the end, we only have two kinds of variables anymore in the entire thing. They're either globals or they're inline, which makes the rest of the analysis super easy. So once we've done that, we can do a bunch of optimization. This is work that we would have previously had to do at runtime, but now we've got this really rich AST, we can do it ahead of time, at build time. And these are the four that I'm just going to skip through now. We're going to be able to skip redundant fields, we're going to be able to remove unreachable parts of the query, we're going to be able to do some flattening, which I'll show, and we'll also be able to filter out unreferenced stuff. So let's look at that first one, skipping redundant fields. So here's an example of a fragment with some nested spreads in it. And you can see here that these fields here in yellow actually got fetched previously at a higher level. No human would actually write this, right? But in practice, this kind of thing can emerge as the fruit of composition. Because you're doing this component like a reasoning thing, you're just asking for the data that your component needs. You're not thinking about how it composes with other components. When it composes, it winds up being this thing that nobody would write. But because we can do static analysis, we can turn this into the kind of thing that somebody would write. And that one becomes this. So those duplicate name and last name fields just collapsed into one. An area where this tends to happen a lot is IDs. Pretty much everything has an ID on it, almost. And you can wind up having ID at a lot of levels, and that'll just collapse down to one level. And that saves a lot of time when it comes to processing the server response, because you're not repeatedly traversing the same field and doing work that you've already done redundantly. Let's look at the second of the 4 optimizations that I wanted to talk about. This is removing unreachable nodes. Now, I told you how variables end up flowing through the entire query and become globals or literal inline values. So one thing that can happen when you do that, you can wind up with a Boolean here that you know to be true or false. And you furthermore know that when it's false, this fragment won't be included. And therefore these fields can just be skipped entirely and elided from the query. So when we run this through the compiler, this one becomes nothing at all, which is great. Finally, we can flatten fragments with matching types. This is another one of those examples that you might not write as a human being if you were sitting down and doing it in a blob, but it can come up in practice. We have here a user spread inside a user spread. Those types match, so we can effectively hoist all that up into this, which is the kind of thing that a human being would write. And the last one that I want to show as an optimization is we can filter out unreferenced fragments. So if somebody ever forgets to delete a fragment when they remove the last reference to it, when we put it through the compiler, the fragment will go away. So you'll notice what all these have in common is they're displacing work that we would had to have done at runtime ahead of time to build time. And so overall, this is kind of what the timeline looks like. We wind up with this hyper-efficient AST that allows us to normalize a server response, when once again, normalize means to process the server response. And we can get to rendering much sooner. The scale on this diagram is not right, so I'm going to show you some numbers in a bit. Let me tell you a little bit about what I mean when I say normalization. The data is going to come in from the network using this hierarchical format that I've already shown you a couple of examples of. Pretty much every field that I request in the GraphQL query is going to wind up with these nested subfields in it. And those subfields can have subfields, and those fields can have links to other fields. So you see here, the viewer wants to know their father, and their father has a pet, which happens to be record number 5000. The viewer's mother also has a pet, which is record ID number 5000. And this particular query, I wanted to know the name of the father's pet and the age of the mother's pet. Turns out it's the same pet, right? So normalization means taking this tree-shaped hierarchical answer and turning it into a normalized flattened response with all of the redundancy eliminated. So you can see here the viewer, which was ID 1000, ends up getting hoisted to the top level, and these things that were links to other records just become data ID links. And the actual data that's attached to the father and mother objects isn't in line here. It's actually hoisted out to the top level. And same with the pet links. So each record winds up existing at the top level, and only the scalar fields exist under the top. And the rest are all links. So that's what normalization is. And it turned out that for a big query, Relay 1 spends a lot of time doing this. So how fast can we make it? Turns out that we can make it way faster. We tested this. These numbers come from a real Android device using a typical newsfeed query, 10 what we call stories, 10 stories. Previously it took about 50 milliseconds to process a single story. Now it only takes 5 milliseconds. Now when you combine this with the incremental fetching that you get from Relay Connection, you're way under the 16 millisecond frame budget. You could render these things at 60 frames a second if you wanted. We were skeptical of this result, so we decided to implement it in native as well. It turns out that native, at least in the first cut, was basically slower. So JavaScript is fast, if you write your code carefully and don't do dumb things. So the combination of writing clean code and having that redundant processing eliminated through the compiler meant that things got really fast. But it's not only normalization that matters. Overall, the number that we most care about on a mobile device is what we call TTI. Who's heard of TTI before? I'm not sure if it's a Facebook thing or an everything thing. Cool, time to interaction. It's basically how long does it take for your application logic to do all its processing, get all the data, put pixels in front of the screen, and be ready for the user to interact. So we do some things to get to TTI faster. Larry Wall, the creator of Perl, said that laziness, impatience, and hubris were the attributes of a programmer. I don't know about hubris, that sounds pretty bad, but laziness and impatience sound pretty good to me. And so this is a list of things that we don't do because we're impatient and because we're lazy. We don't build large query strings at runtime anymore. We don't upload them over the network. We don't do any of this diffing stuff. We don't do a thing called computing query paths. I'll briefly describe that a bit later. We also don't do any fanciness around mutations and track queries. And finally, we're not doing splitting of deferred queries at runtime. We're doing it at build time instead. So I'm going to go into, there's a few more things that we can do if we want to. One is we don't have to take the response off of the network and shove it into the cache and then render. We can actually take it off of the network and render it and then shove it into the cache. Another thing we could consider doing is pre-normalizing the responses. So instead of sending a tree over the network, why not send that flattened representation already? And yet another possibility that we could do, because of the way we've architected this, is we could actually store those records, have the cache live on the native side. The native side could be doing the work of the normalization ahead of time, before the JavaScript context is necessarily booted. And we can share the records via a bridge. So, what happens when you build a relay that doesn't have diffing anymore? Diffing was one of the kind of radical and original ideas in Relay 1. The trouble with diffing was that it brought with it immense complexity. It had runtime overhead because we had to compute these things, and it was marginal benefit, especially when we're talking about optimizing for TTI. It turns out that even if we throw diffing out the window, we can get back a lot of the gains. So we still keep a simplified version of diffing. It's the kind of Boolean check. Do I have all of the data I need necessary to render this view? And if so, render straight away, don't hit the network. What we're not doing is that field by field diffing where we try to build up a partial query that represents only the data that we need. So this is good. It's much easier to reason about because there's no magic going on behind the covers. If you want to fetch some data, instead of using a set variables API, you just give it a query and say, fetch this data for me now. And this in turn is a little bit more manual, but it leads to a better schema design. Because if your schema is hard to interact with and it's difficult to refetch data, you're going to find out about it. Instead of some arcane black magic deep down in the bowels of Relay, which is hard to understand and hard to troubleshoot, the problem is right there on the surface, and you can actually fix the schema. So, as I already mentioned, you still get the joy of split deferred queries. In fact, you may be getting it for the first time because I don't know if anyone outside of Facebook has ever built a network layer to do the splitting effectively. But through a defer directive, we're going to make it easy for people to be able to do this. And so all this work is going to happen at compile time instead of runtime. You get it for free. It's a zero cost abstraction. So in order for split deferred to work, we need to be able to send a batch of queries because, like I said, splitting a query means turning one query into multiple queries. And you don't want to send them all one at a time, do you? You want to deal with them in a batch. And similarly, if you're building something like Relay Connection, you want to be able to stream down edges one at a time. So you need something else that's kind of batch aware. So we need a network layer that's capable of dealing with queries in groups. So we've built this client-side batching adapter. Basically, at runtime, you're going to get a batch of queries that needs to run. This adapter knows how to deal with plural queries. And in its default form, it's actually going to make multiple round trips to the server. And the GraphQL server is going to make potentially multiple round trips to the storage and feed these results back to the client. Why are there multiple round trips? Well, it's because query batches can have dependencies that relate them. One example of this might be getting a list of posts on a blog and wanting to defer the comments on those posts. I can't start fetching the comments on the posts until I know what the posts are. So there's a dependency. I have to fetch the post first. Once I know the ID of the posts, then I can start fetching the comments. So that's why you're going to have multiple round trips. It's also possible that queries won't have dependencies between them, and those they can be sent in parallel, and that's what our adapter does when it can. Another example of where the multiple round trips happens will be in the streaming connection thing. I might ask for a list of 10 items, and the query is going to look something like, give me the first item after cursor null, because there's no cursor yet. But as soon as I get that first story or post back, I'll have a cursor. And I can rerun the query again and say, give me the first one story after that cursor that I just got. And I can rerun it again and again, 10 times. or whatever I specify as a count. And each result, as it's read out by the server, will flow back over the network, and we can process it. In reality, that diagram I showed of what happens on the server isn't quite accurate. In a real production app, it's going to look more something like this. You're probably going to have a library like Data Loader, which handles aggregation and batching, and that's going to reduce the number of requests. Because Data Loader knows, for example, that if you've asked for user ID 4 and you asked for it only a few seconds ago, it can just give you the same one back. It also knows that in an asynchronous world, it can actually wait for a bunch of these things to accumulate and get like all of the users at once, and do a smaller number of round trips. You probably also have a caching layer between GraphQL and your actual storage. It might be memcache in front of a MySQL database or some other cache. So that's the reality of what happens on the server. But in any case, we have this client-side batching layer. But you can move that batching layer to the server if you want. Why wouldn't you? You don't really want to make a lot of these round trips across the network between your mobile device and the server. But round trips within the data center are probably okay. So if the adapter is written in JavaScript and your server is written in JavaScript, or you can at least run JavaScript in the data center, there's no reason why you can't run the adapter on the server and speed up things massively. And finally, just for historical reference, we took this idea from a batch design that existed in Facebook and has existed for years. We already had a batch endpoint that knew how to run things repeatedly or establish dependencies between queries. We've really just extracted it out. So this is something that I'm really excited to have finally come out into open source. So we're almost at the end. Mutations is something that we've decided to tackle with Relay 2 because it's the first thing that people complain about. Mutations in Relay and in GraphQL in general are how you modify the data. And they involve quite a bit of configuration and a very steep learning curve. And we realized that maybe declarative APIs, as wonderful as they are, aren't actually a good fit for mutations. So in Relay 2, we figured, let's take this thing, which is a fundamentally procedural operation, mutating data, and something like toggling a Boolean or appending to a list, and let's make it look imperative, because it really is. So we have to change a couple parts of this system. What is a mutation? Well, it's really four things. One is, it's a name. It could be something like add comment or like post. That tells the server what mutation to actually run. It's a variable that contains information necessary to perform the change. So if you're adding a comment, you obviously have to provide the comment text. If you're liking a story, you have to provide the identifier of the story. But it's also a query, because when you've changed the world, you want to get an updated worldview of what things look like now. So you specify the data that should be fetched with this mutation. And finally, it's configuration. It's what should I do when I get the data back from the server? So a lot of this stuff was awkward in Relay 1. Let's look at what it's like in Relay 2. Well, in Relay 2, just like everything else, mutation queries are totally static. We don't have fat queries anymore. Fat queries was this really clever idea in Relay 1 that basically corresponded to all of the data that might change as the result of a mutation occurring. So an example would be if I like something on Facebook, what could change? Well, the viewer did like field might change, the list of likers. We have a thing called a likers sentence. All of that could change, and that would be in the fat query. But there are some mutations for which it's really hard to write a fat query. Like what if I unfriend someone? Like that could pretty much change everything. What if I log out? That's also pretty obviously going to change everything. So we're throwing all of this cleverness out and replacing it with dumbed down static queries. You write exactly the data that you want to get back when you make a mutation. It's more predictable and it's dramatically simpler. And it also makes the implementation dramatically simpler because it means we can throw out these people. We had these things called track queries. And the notion was, you would take a fat query that describes everything that might change, and you would take a track query, which describes everything that you've previously requested about a particular record, and we would intersect them. Because if 20 fields might change, but I only have 5 fields in the cache, I don't need to request all 20 fields. I can just request 5 fields. The trouble with these things is they need a lot of CPU to actually compute them. They occupy memory. They make garbage collection harder, because we have to get rid of them. And they add a hell of a lot of internal complexity to the framework. So by going static and by getting rid of fat queries, we get rid of track queries. And finally, the last part we've tried to fix is the Declarative Configuration API. This is an example of the imperative style that we're using to get rid of that hard-to-learn declarative stuff. This is what a so-called optimistic update would look like in Relay 2. Basically, we give an API that allows you to pull stuff out of the cache, read fields off it, change them, write them back. We can maintain these things in a queue. We can update the UI immediately to reflect the new data. In this case, I've updated a view count. I can show that on the UI straight away. I don't have to wait for the server response to come back. When the server response comes back, I throw away the optimistic update, I apply the real update from the server, which once again can be written in this style. How to process the query response, just write it in the imperative style. The other thing that I'm super excited about, client-side fields. So Relay's always been so far about exposing server data to the client perspective. And if you wanted to do complex client-side state, you had to use something like Flux or React internal state or Redux. And you could use these two things together. You could use Redux on the client side for some things and Relay to get your server data. But it was very much a assembly required kind of operation. You had to do everything. You had to do all the work yourself. Certainly possible, but not easy. And so in Relay 2, we've decided we want to make this possible to manage client-side state seamlessly with server state using Relay through the addition of client-side fields. You still probably have a use case for React state. There's probably always going to be that. You know, for example, if I'm dragging something, I clearly don't want to have that in the Relay store. But a lot of other stuff can live quite happily in the Relay store. And so the way we do that is using this extend syntax, which is available in GraphQL. We can do this. We can use this to add fields to existing server types. In this case, I'm attaching a drafts connection to all users. We can also add entirely new types. So here I've made a thing type. That's a name I will probably regret actually 6 months from now when I look at it. But we can add new types to the schema as well. And so in terms of what this means for Relay, we just have to teach our toolchain about how to process these client fields. The client fields are going to get stripped out of all the server interaction because the server, by definition, doesn't understand them. And also by definition, it will never return data for a client field. And then on this client side, you can provide a handler, once again, arbitrary imperative style code that does pretty much whatever you want to synthesize data fields in the local store. And because they just look like any other field, all of our existing garbage collection and synchronization stuff will just work with these things. So summarizing, these are the reasons why we're excited about Relay 2. Everything's going to be static, which makes it fast. We've realized that we can use GraphQL polyfills to have whatever we want, whenever we want. We've got parameterized fragments. We can do whole program analysis, which enables a whole new world of optimizations. We've got much better mutations, and we've got client-side fields. So we feel like when you sum all these things together, we've got a framework that's so much faster now. And it's so much simpler, both for us to implement, but also for users to actually grok. Because we don't have fat queries anymore, we don't have diffing, we don't have tracked queries. And all of that makes it more predictable for everybody. So there's a lot. I know that Pete said that Relay had a lot of magic in it, but very soon it's going to have a lot less magic in it. So you probably want to know when you can start using it. Our current status, we've done the compiler. It works. We have a prototype of connection. We're working on mutations still. Just today, actually, Yuzi was working on mutations. And we've got our first mutations actually working. We've got optimistic updates as well. And we're still experimenting with the client fields API, but it's looking promising. And obviously, you're going to want a migration pathway, right? A fortunate thing about Relay is that the API is actually pretty small. So there's not a lot of stuff you have to do to move from Relay 1 to Relay 2, despite the drastic changes that we made to the internals. And to make this easier, we're going to provide a compatibility container. So the idea is that you're going to be able to start down at the leaf nodes of your application, pick one component that's currently written in the Relay 1 style, make it static, code it against the Relay 2 API, and our compatibility container will at runtime turn it into a Relay 1 component. And then you can work up from the leaves all the way towards the root. Eventually you'll have an entire application that is built in the Relay 2 style. And once you've got that, you can throw away the compatibility layer and stuff will get dramatically faster, or at least that's what we hope. Pretty sure it'll get faster. So we're trying to get this into production at Facebook before the end of the year. I think the first thing that's going to happen is going to be the Pokes dashboard, so get on there, start enjoying Pokes. But then obviously we'll move on to like media products. And we want to bring it to the web and obviously to open source. So stay tuned, we're going to be getting it out there as soon as we can. And that is all. I'll be uploading these slides somewhere and then linking to it in the docs on the site. That's my GitHub handle and my Twitter handle, so I'll also like post the slides there. So that's all I got for you at the moment. Like I said, I've got a couple of colleagues here who'll be able to answer questions in a bit. So thank you very much for listening to me ramble on so intensely for this time and staying awake. Enjoy a break, have some water, beer, pizza, whatever, and we'll come back in a bit for Q&A. Thanks.
You guys kind of just run with it, but maybe I can kick us off with one that came up before, and maybe the story is different now with the whole static queries and everything, but someone had asked at a previous meetup, and maybe it's a little more GraphQL specific, but maybe you guys have answers here of like, what would you do with caching of query responses on the edges of a CDN, like distributed around the world? And how does, maybe Facebook has a unique solution for that given the scale of your infrastructure, but are these query responses cacheable around the world, or does it have to kind of come back to the source of information each time? And then maybe whoever's answering come to the mic for the benefit of everybody and the camera recording.
I mean, I can attempt to. I don't know that I'll give a good answer. Do you?
You go.
Okay. Yeah, so at least as far as I understand, GraphQL is basically like, it's a client-server interaction, so you could presumably set things up so that the client's, like, what it caches, it can be cached the same way globally, but we basically, at least within Facebook, we expect every GraphQL response to actually be hitting a specific server, or like actually be running against some thing that can give responses. And so that thing that gives responses, the thing that is the function runner, essentially, like, will be consistent to the, or mostly consistent to the client, but doesn't necessarily, like, I don't think we do any setup to make sure that, like, oh, no matter where you are in the globe, you'll get the same thing back.
The other thing that I would add is that it's incredibly like application specific what semantics you want to have when it comes to caching. So, if you have a read-only app where there's no login, like, you could cache it like beautifully anywhere you want. Obviously at Facebook, we care about having up-to-date data, so a lot of our caching, is going to be much more aggressively invalidated. Especially with the example I gave before, like if somebody unfriends you, like that means you shouldn't be able to see their stuff like right now, not a few minutes from now, and so yeah. And as you know, like cache invalidation is the hardest problem in computer science. So.
One question about the next. Should I come to us?
No, you're all right.
Okay.
Yeah.
So, is it like open sourcing, which we are doing with new related to? Is it like in GitHub? You like, or it's somehow like locally and internal?
We've been working on it.
Can you repeat the question into the mic as well?
So the question is, how is Relay 2 being developed in terms of open source and visibility and stuff like that? At the moment, it is in our main native app repo. We're trying to figure out the best way to get it onto GitHub, because until it can actually be used in any kind of useful way, there's a bit of supporting tooling that needs to be made. And so it might be that we put it on a branch. So we don't really yet know how that's going to be, but August is the month where we wanted to start talking to people about this and giving people more information and starting to get feedback. And so hopefully, certainly before the end of the year, but we obviously don't know exactly when, we want to get this out to where people can actually start using it. So yeah, we want to get to GitHub as soon as we can.
It would be really nice to get something like React Team did with core team notes.
Yeah.
About something which like you're like thinking about some decisions, and maybe a community might help or something like that.
Yeah. So the comment there was that it'd be nice to have something like React core team notes where they go into like considerable detail about what they're thinking about. We've tried to do this in a kind of subtle way in terms of our meeting notes. Relay 2 is a kind of high risk project, and it was tied to a lot of like React Native stuff, so we had to be a little bit kind of discreet. And if you've been looking at the meeting notes that we commit to the GitHub repo, you'll notice that sometimes they're a bit vague. It's like, did something on prototype.
Yeah.
So now you know what we've been doing this whole time. And we're really kind of excited. This is literally the first public occasion that we've been able to give people details. It means that we actually can, from this point forward, be much more detailed in terms of what's happening, and we can actually get eyeballs on it. And the scenario that you described where like people can help out, that's actually ideal for us, because there are so many things you could build on top of this, and we clearly can't build them all, and it's exciting to think that somebody else with that use case can come in and actually deliver that without us having to do it.
So is the static analysis of the queries happening as like a Babel transform? Or is it something more like a flow server or something?
Yeah, so it's all just kind of vanilla JavaScript. The question was, where is the static analysis happening? Is it a Babel transform? So we're using the GraphQL parser from GraphQL.js to give us an AST of those fragments that we extract from the components. But then our compiler is basically a modular set of very small, like single concern transforms that each do exactly one thing, and they're just simple JavaScript modules. So the first thing we do is we take this AST that we got from the GraphQL library. It's a little bit inconvenient to work with, so we transform that into an IR, an intermediate representation, that is more convenient for our purposes. It has some redundant indirection removed, and it has more types, so that, for example, things like the conditional that I showed, we don't have to look at all of the directives on a field and check if any of them are conditional and check what the value is. We can just see, oh, this node in the AST that I'm looking at is a conditional, like straight away. So that's made the code a lot cleaner. So they're all generally small JavaScript modules, could be like anywhere between 50 and 250 lines long, that do one thing, like flattening or auto-aliasing or adding requisite fields or doing the optimizations that I said. And because they're running at compile time, we don't have to worry too much about performance. We basically just have to avoid doing stupid things, because eventually, as more and more people use Relay 2 at Facebook, we're going to have to worry about runtime performance. But at least, as long as we're linear and not quadratic, we're fine. So we write things with readability in mind, because we want to move quickly. We want this thing to be bug-free, so we just have these like really simple transforms.
So is the output of the compiler like additional files or strings in the top of files, or?
Yeah, so each transform takes this intermediate representation and emits intermediate representation. At the end of the pipeline, you've got the intermediate representation. You can turn it into something else. What we turn that into is what we call a concrete AST, which is that JSON-like thing that I showed. And using that, you can do whatever you want, including like printing a query, dumping it in a file that you can like require, like a module, persisting it to a server. Effectively, we are storing these things at the moment in files. Because we have another Babel transform that like takes the inline ES6 template literal that I showed on the screen and turns it into a require that requires in the concrete AST that I showed on the thing. But nobody needs to know that those files exist unless they're building tooling. So.
You said that there would be no diffing anymore, but don't you lose the benefits of the network saving if you like fetch again the same data?
Yeah. So, just for context, the iOS app at Facebook has never had diffing. So the iOS app deals with really hard network connections, really hard network connectivity all the time, and we have found that the basically any network request, you have two pieces, right? You have the upload, like the actual request to the server, and then the download, right? So by diffing, you get the benefit of your upload being smaller than a string query, and your download being smaller than it would have been before. However, so there's a few reasons why persisting and having consistent queries is beneficial and why the downsides to the download part aren't that bad. So the one reason why the upload persisted query is just better. No, you basically can't create a diff query until it's a 0, in which case it's the same whether it's persisted or not. But yeah, you can't get the diff query to be smaller than the thing that you request with the persist ID. Then on the download side, because GraphQL is strongly typed, you're only getting a response back of the fields on types that you've specified. So I could have a very large query that has hundreds of fields across 5 or 6 different types. And what we found is like the diffing part will likely basically resolve to one of those types because, oh, that's the type that you didn't request before. So now we only need to send up that type's part of the request. Well, that means you're getting back the response for that whole type. So like the end game is, yes, the response sizes are a little bit larger, but it's not multiple orders of magnitude larger. And uploading is almost always, especially in bad network conditions, is the thing you need to reduce as much as possible.
And also to add to that, like, what? You can just probably, okay, yeah. So another thing inside Relay 1, so like all the queries are a lot more declarative. So for example, when you want to paginate and load more stories or something, you change the variable from like, I don't know, first 5 to first 20. And then, or like, let's say you want to fetch like more comments or like maybe a different profile picture size, you change the variable. And what Relay 1 does is that it essentially uses that entire query and so that like kind of includes both the information we already have and also the new information we want to fetch, and like kind of that's a bit inefficient, so we have diffing in there to kind of remove the data we already have. Inside Relay 2, you can have more imperative ways of writing these queries. So let's say you already have a query that says, okay, get the first 10 stories. With the the Relay Connection API, you'll be able to write a query that essentially only fetches for like the first 10 after the 10th story. And in a way, a lot of these will give you more flexibility in terms of exactly what data you want to fetch. So if you want to fetch from the beginning, fetch from the end, it's easier to express that inside Relay 2.
Yeah, because right now we cannot do like fetch the after like starting from page 4, for example.
Right, exactly. You'll like inside Relay 2, I think we'll probably have like a default implementation that's kind of similar to Relay 1, so it's easier for people to transition. But we'll also make sure there'll be ways for you to sort of inject your own connection logic. So hopefully you'll be able to handle mutations and also the paginating from the fourth page, or also handling other things like easier to do pull to refresh. So you want to fetch more on top of what you already have.
The one final thing that I would add about getting rid of diff queries is that people who do analysis on queries love persisted queries. Because with a diff query, you don't really know what's ever going to be sent, and like different people are going to have different pathways through the app and then request different data depending on what's in their cache. But with persisted queries, you're just going to get the same queries over and over, and you can make pretty charts of them and do all sorts of nice things about CPU usage and like your field is costing too much, you should change it, etc. So it just makes it much easier to analyze like aggregate data workload at the server side.
There's a question way in the back. Can you talk about relay and offline usage?
I can talk about it. Yeah, so Relay 1, we've done some amount of work to so part of this, honestly, part of Relay 2, from what I understand as a person who works on the team adjacent to the Relay 2 effort and gets to muck around in the code base. One of the things we wanted to be able to do is basically not make queries that you've already made in the past, and that includes not making queries that you've made across sessions, right? So like you should be able to cache things to disk, and then if you bring the app back online when you have no network connection, you should be able to see the things that you've already seen and make mutations, so make actual changes to the data without needing a network connection to do that. So we've done, so like with Relay 2, this actually potentially, so it's possible to do in Relay-ish. I don't know. So I know with Relay 2, this is like one of our actual goals where if we have the data for you, we will show it, and we should be able to read that data, whether it comes from like the runtime relay store or some persisted disk store. Like that should just work, and we should have basically the various modules to allow us to hook into different stores. With Relay, the store is complex, so like. Yeah. No. Usually probably not as best.
So with Relay 1, we actually have like an internal sort of more experimental disk cache module that allows us to essentially read data from disk when there's no network connections. And like you can probably see snippets of random places, like I think it's like insert or inject like disk cache module or something, but the API is still pretty experimental. We don't support a lot of things, so we haven't been like talking about it more widely. But that's what we're testing internally, and it does allow kind of loading from like rendering data from disk cache, and also I think one of the product teams were also kind of experimenting with offline mutations as well, where they store some subset of metadata where they will try to replay next time there's network connection. But it's definitely something we'll look into for Relay 2 and try to have it more widely.
As a general point, I think that's an example use case that would be really well met by a community contribution. We've tried to make the core much smaller and much simpler, precisely so that people can build things on top of it, like disk cache. Because the reality is, like, we have our proprietary disk cache, and we're probably never going to open source parts of it because they're totally wedded to our internal infrastructure. But certainly somebody else can come in and plug something in.
For the building like a persistent query, do you do it at each component level, or how does it know like where the root of the query is for building the static one? Yeah,
so you can only persist queries, you can't persist fragments. A query may reference fragments, and so that would just become a GraphQL document. It's always going to have a query and the fragments in the same document. So yeah, because we do this static analysis of the entire application, we know literally what all the fragments are. We know what all the queries are because we made the users write them, and so we can persist them.
So like currently, like the renderer, the Relay renderer roots it. Like, so do you like look for those, or is it different in Relay 2?
Well, at the moment we don't have a name for what that top level thing is going to be. So yeah, I don't have a defined answer for you, but there's going to be like a finite set of entry points in the application that you'll be able to persist. And sorry for not repeating the question. It was about how we discover what queries to persist within the app, and whether like individual components have little bits of persisted.
What's the documentation process in Facebook itself? Because like the context of the question is that for current like Relay 1, documentation is not really like great. So and you have to like deep inside to understand some concepts. So what's the process of like documenting stuff and other things?
They take PRs.
We definitely take PRs for documentation. But as a user of many of the things that have been open source, the documentation that we provide with open source tends to be most of the documentation that we have internally. Unless we have like some internal API that is different from open source, we like with Relay, we redirect people from our internal documentation to the open source documentation. So all the pain that you go through, all of our internal developers go through too. And it ends up like a lot of the documentation ends up being like people reading through examples and then doing it and then getting like, yeah, we would love to have better documentation, but that's work, right?
It sounds like most of the documentation is going to be done by community or something like this.
We'll see. It's kind of too early to tell, right?
Okay.
But I certainly feel like our documentation could be better and should be better. I can explain a little bit about the psychology behind this as well, which is that we feel that documenting something is establishing a contract with somebody that they could expect something to behave in a certain way over a prolonged period. And given that Relay has been a highly experimental project, we wanted to preserve what we call option value, the ability to change our minds. And so often what we'll do is we'll add a new API, but we intentionally won't document it. It's not because we're lazy or because we want someone else to do it, it's because we want to just be really sure that this is something we want to commit to supporting.
Yeah, and community should be also sure that.
I personally think we've probably moved that needle too far, and we could actually afford to. We're too risk averse about documenting things. We should be more open to saying, yeah, this is a thing, and this is the API, and we're going to do our best to maintain it or provide a compatibility pathway. Because you have to break eggs to make an omelette, and we want to make omelettes. So.
Is the viewer type going to stay as a best practice at the top level?
So the question is the viewer type going to stay best practice at the top level? None of us are on the GraphQL server team, and so I don't want to speak for them and say something that's totally wrong, but if your app has different data depending on who's viewing it, then probably that makes sense to have as a top level field that you can query against. But I can imagine many different apps where it never makes sense to have a viewer, for instance.
I think he's more so talking about the workaround where you have you have to nest things under viewer to get the array responses and stuff like that.
That's those limitations are going away. These are not the droids. Oh, no, they really are going away.
This is so you had a slide where set variables is going away, and you mentioned it a little bit earlier as well. But for pagination, how does a component know which query? If a component can belong to many top-level different queries, how does it know which one it needs to rerun or?
Yeah, so the query will be co-located in the component. So if you want to refetch a connection, you're going to have the top-level query in your component. Once again, this is partly externalizing the complexity of the chore of data fetching onto the user, but not out of laziness, but in a calculated way so that people understand exactly what will happen when they request more data. And so if something is difficult to fetch because it's nested through 20 layers of indirection, then maybe you should change your schema.
I think another thing with Relay 2, correct me if I'm wrong, is that I think overall we're trying to make the whole, I guess the equivalent of right now, Relay Render, which has all the top level fields a bit more lightweight, so it'll be easier to sort of embed them in the middle of your application as well, so that you can have more root queries in different places.
Maybe not directly about Relay, but are there plans to open source some of the native clients?
Yeah. So my team, you could think of, so I work on what we call iOS graph services, which is basically all the things we're doing for our iOS client that are very similar to Relay. We are moving to a world where those pieces, we've built up pieces of GraphQL infrastructure in C++, for instance. And those pieces are getting less and less tied in specifically to our iOS client, and we're beginning to get the capability of using them internally across clients, but that has been a multi-month, multi-year, multi-person type effort. And it's unclear what the right thing to open source even is, because we didn't originally build this with the idea of open sourcing, and we're only now coming to the realization that like we share a lot of similar implementations, similar goals to Relay. So the native clients, open sourcing those, it's not that we don't want to, it's that we don't want to give the open source community something that's like a hodgepodge of like Facebook intermixed with things we never use in Facebook. Like, we'd much rather say, look, you can do everything that we're doing with Relay 2 right now, and hopefully we will have native solutions for similar problems down the line. And when we do, like, we also are hoping, because Relay and the native solutions were built basically independently of each other, we're also hoping that when we offer a real solution, it would be able, like, if you use Relay and use native things, you'd be able to reuse and like share the implementation. Until we get to something approaching that state, probably not. And so there's no timeline for this to happen, but that's not to say it's off the table.
I have one. Kind of a little bigger picture, I guess. Do you guys, I think you've talked with some other people maybe offline, but for the benefit of everybody and me, do you guys have kind of in your mind a story for real-time updates being built into Relay and GraphQL? Essentially, in my mind, it'd be an offering similar to Firebase or Horizon with RethinkDB, but you know, is that something you guys hope to tackle, or what's kind of the story there?
So the question is real-time updates similar to like Firebase, etc. How do we hope to tackle that?
Or do you hope to tackle that?
Yeah, that's a good question. I don't know.
Okay. So we have, I mean, I think if you look at the way the world is trending, like real time is something that's becoming more and more important in a wider and wider range of apps. And so obviously it's something that Facebook is interested in. And the question is, at what point does that interest intersect with what Relay is and what Relay is trying to be? And some evidence of what it has been historically is already visible in some places in the code base where there are a notion of like subscriptions in there. But within Facebook, we have other initiatives. It's a large company. We generally try to solve a problem in more than one way and figure out which way is the best way to do it. So it's not clear that that version of subscriptions, which we've built into Relay, is like the one that we should be betting on, or that anyone should be betting on, really. And so one of our hopes is that because the core is simpler now, people will be able to build liveness on top of it. And the stuff I said about polyfilling GraphQL is probably the way that it makes most sense to do so. You can imagine that in a complex app like Facebook, you don't actually want every field that you've ever queried to be live, because it literally would not scale, no matter how much money you've got in the bank and how many servers you've got in the data center. There always has to be this element of discretion where you say, like, this is data that I want to be live, and this is how stale I'm prepared to accept it, and this I kind of want it to be live if it can be, but you know, I'm prepared to accept stale, and this one I just don't care about at all. And that kind of decision is going to be made at multiple levels across the app and across multiple teams. And because of that, the kind of nuance to it, like, there's not going to be a one-size-fits-all solution. But you can imagine having a directive, a GraphQL directive that could be something like live or stream, right? Where you could denote a place in the GraphQL query where you say, like, from this point onwards, maybe until some other place where I say I'm not interested, or maybe in a shallow way, maybe in a recursive way, I want to be notified of updates. So we certainly have ideas about what something like this might look like, but because the semantics are so complicated, it's not even clear what the solution should be. it's unlikely to be something that we're going to build in the near future because we have a lot of work ahead of us optimizing for that TTI use case on mobile devices and making it as fast and slick as possible. But we're super excited about the possibility of other people jumping in with solutions that fit their scenarios.
I have a question around the global IDs, so not really the internals, but in Relay the global IDs are like the type and the internal ID and base 64 encoded. So how do the people who use Relay make it look like in the UI like the real ID? Like for example, I have users and like people who use my website use the ID, and
Generally, probably try not to like base 64 encode it in the client side. Might get messy.
okay.
Cool. We'll do this little time for community closing announcements. Let's see if I can steer the